Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So we have a medium today. It's called find closest node to given two nodes. So we're given a directed graph of n nodes. So I think that will be the edges list, and then we also have two nodes. So I think like there will be some node within this graph. And how big is the graph? So the graph is up to 1000. Well, 1000. It's up to 100k, and yeah, all of the rest are basically what you would expect. Oh, actually, for this one, edges I is not equal to I. So does that mean every node can only connect to one other node? Is that what it is? Or so yeah, n is equal to edges dot length. Okay, so n is actually the number of edges. Okay, I see. So instead of having like a list of, like 1 2 2 3, basically what it does is it stores. Yeah, well, I guess that means you have like n nodes, but let's just read the question first. So yeah, where each node has at most one outgoing edge. Yeah. So the graph is represented with a given zero index array edges of size n, indicating that there is a directed edge from node I to node edges I. Right, so like so as I said before, like we're connecting from I to like whatever it has there. If there are no outgoing edge, it would just be -1. So actually what that means is, because each node could only have one edge, we can only have one cycle at most. Yeah, it does say that edges may contain cycles, but that means we can only have one cycles at most. You're also given two integers, node 1 and node 2. Oh wait, actually, that's not true. That's not true, cause like, you can have multiple cycles. If you have multiple cycles, you actually have like multiple components. But okay, so you're also given two integers, node 1 and node 2. You want to return the index of the node that can be reached from both node 1 and node 2, such that the maximum between the distance from node 1 to that node and from node 2 to that node is minimal. It's minimized. So if there are multiple answers, you have to return a node with the smallest index actually. And if no possible answer exists, we turn -1. So note that edges may contain cycles. Right. So yeah. So let's look at some example first. So this one, node 1 is 0, node 2 is 1. So I think it makes sense that it makes sense that 2 is the node that we want to reach, I think. So the distance from node 0 to node 2 is 1, and the distance from node 1 to node 2 is 1. Yeah, so yeah, actually it is directed as well. So if instead 2 is pointing at 1, we actually can't reach, from 1 to 2. So we have to be mindful of that as well. And obviously 2 is better than 3 because the distance is minimalized. So the next thing we have to look at is let's look at example 2 actually. So we have node 1 is 0, node 2 is 2. So the distance from node 0 to node 2 is 2, and the distance, so the node could be itself as well actually. So the maximum of those two distances is 2. It can be proven that we cannot get a node with a smaller maximum distance. Well, actually, because you can't reach 0 or 1 with 2, so you actually have to pick 2 in this case. Right, so let's think about how we can solve this problem now. I think there are a lot of ways to solve this, but my first thought is we can actually do a BFS from the two nodes. So if you do a BFS, we can like keep getting the like the nodes that are seen. Um, yeah, so we can like keep doing that. Um, and like basically when we reached a node that is like basically when we BFS, like we can find the distance for like all the node, like our node 1 and node 2 can reach, and we can also get the depth of those nodes. And at the end we just have to like we just have to find nodes that that are in, well, that are in both sides, and um and we just want to find the minimal for that. So basically what I mean is, if I draw it out, so let's say like 1, 2, 0 and 3, so that's what we have. Yeah, so what we can do is we can do BFS from these nodes. So these will be like depth 0, right? So let's look at 1 first. Well, 1 can reach like 2 and 3, right? And 0 could reach, well, also 2 and 3. And then we just look at all the nodes that are seen. So like node 2, and then like you have node 3. So both of these are overlapped, right? And then like we just want to like sum the depths up, and we just want to find the smaller one, like the smallest one. And like we also have to account for the index as well, obviously, but we can like deal with that easily. So yeah, I think we can start coding now. So we need two BFS. Yeah, so if we need two BFS, yeah, also it's quite interesting that every node only goes out once. So that's something we have to think about as well. But I don't think that should affect the answer too much. So yeah, let's just code it out, I guess. So we want to BFS from node 1. I guess we have like a scene 1, and then we also need to know the depth for all the nodes that are seen. I guess we don't need that then, because like our map should be able to do that already. So yeah. So what we can do is we can have a queue, and we will put node 1 in. So just like yesterday, like we'll do a BFS using, well, 2 arrays. So like new queue is going to store the nodes in like the next depth, and then like we'll update that like into queue. So like we'll just do this. So let's say this has depth 1. So we put the stuff in here, and then and so that will become like queue here, and then the next new queue is going to store depth 2 and so on. Right. So what we want to do is we want to do while I guess like for node in queue, we just want to get the next thing. So that will be edges node. But then if next is -1, well, we don't want to we don't want to like go into it, right? Like we don't want to go into 1, because, well, like 1 basically means like there are no edges. So we just want to continue for that case. Yeah, we also need a depth counter, and then like we'll append it here. Actually, do you want to append it there? I think we can also append it like up here as well. So yeah, and I guess we have to put like node 1 is 0 up there, and then like we'll add the depth here. Well, I guess it doesn't really matter, but like basically when we are adding nodes here, we want to be able to like add the depth here. So that's like the only difference. Well, I guess like the other thing, like when we want to skip, is we see a node that we have been to already. So we can do something like next in depth one. Otherwise, we can just add next. Well, actually, we can add depth one next. So that will be equal to depth. And we also need to put it into the queue. So next, something like this, right? Right. So after we do that, we should have all the depth stuff in depth one. We also want to do the same thing for node 2. So node 2, we have depth 2 and node 2. We just have to make sure we update everything correctly. And yeah, what else do we have to change down here actually? Yeah, depth 2 here. So all these should be the same. Yeah, so if we print out depth 1 and depth 2, so let's just make sure like we are on track with our BFS. So we can look at example 1 and see whether we are getting the correct thing. Yeah, okay, so this is exactly what we want, right? Like what I've drawn here, like 0, 1, 2 and 0, 1, 2 for like 0, 2, 3 and 1, 2, 3. So yeah, that's what we want. Yeah, and also like the way I do it here, like with checking whether we have seen a node already, that would automatically deal with cycles. So we don't even have to worry about that. Right. So right now we just have to go from from 0 all the way to n, I think. Wait, but yeah, again it doesn't tell you what n is, so you kind of have to. Oh, I guess you can use the edges, the length of edges. So for I in range. So because like if we have n nodes, we have n edges in our case, right? So we can just check like that. And so we have the index, and then we also have the minimal. So we just do like infinity for now. So so the first thing we want to check is whether node I is in both depth 1 and depth 2. So if I not in depth 1 or I not in depth 2, well, we just want to continue. But now we know that I is reachable from both of our starting points. So what we can do is we can just we can compare with the running minimal now. So if depth 1i plus depth 2i is actually smaller than our minimal, well, actually it has to be smaller, because remember, if it is equal, and because we are looking at each node in order, we want to return the smallest node, the smallest index, right? So we actually like have to beat it in order to like want to update the thing. So minimal will be equal to, just copy this. Yeah, just copy this, and then at the end just return that. Seems like it works. Oh, rip. What is this case? So our output is 4, but then the expected is 1 here. Also, I'm only failing like 3 cases, so that's kind of strange. It could be because like it has cycles though. So 0 goes to 4, 1 goes to 4. So we actually want to start from node 5 and node 6. So 0, 1, 2, 3, 4, 5. I guess we can just print these out. I think that would be easier. Yeah, I'm probably just missing like one thing. Like if I have to guess. So output is 4. Well, it's 4 reachable from both of them actually. So 4 we have 4 here, and what about for 1? Right, so here it is suggesting that to get to 1, it actually takes 3 steps. So is that true? I guess one way to do it is to just draw the example out, which is not the best way, but we can just do that. So 0 and 1 both goes to 4. 2 goes to 8. So 2 goes to 8. And then 3 goes to nothing. So 3 is just by itself, I think. And then we have 4 that goes to 9. We'll draw it here. So 5 goes to 8. 6 goes to 4. 6 goes to 4. 7 also goes to 4. 7 also goes to 4. And then 8 goes to 1, and 9 goes to 1. So I guess we can just put 1 down here. And then, of course, 1 goes to 4. So what are the 2 nodes that we actually want to go from? So I think it's this node and this node, right? So yeah, actually, like, to reach... Wait, now I'm kind of confused. So the answer is saying it should be 1. But if you look at the graph I have drawn, it actually it does take 5 steps to get to 1. But for 4, it actually only takes 1, 2, 3, 4. It actually only takes 4 steps. So I probably misunderstood the question somewhere. Return the index of the node that can be reached from the maximum distance between... Yeah, the distance from node 1 to that node and from node 2 to that node is minimalized. Yeah. So if there are multiple answers, return the node with the smallest index. I don't think I misunderstood the question. So I'm actually not sure. Yeah, I'm actually not sure what's going on here. And like what I print out here is also correct. So the graph is represented with a given zero index array, indicating that there is a directed edge from node I. Yeah. So if there's no outgoing edge, you're also given 2 integers. So you want to return the index of the... So I think if I misunderstood something, it will be somewhere here. So return the index of the node that can be reached from both node 1 and node 2. Yeah, so both 1 and 4 are reachable from 5 and 6, such that the maximum... Oh, I think what it wants is not the sum of the maximum. What it wants is the... Like, not... Like, so what they want is actually not the sum, it's the max, I think. I think that's That's what they're looking for. So I should actually do that instead. And I think that should fix the problem. Let's see. Yeah, so it actually wants, so let's say you have like depth 2 and depth 3. The maximum here actually means depth 3 instead of like the sum of it has to be minimalized. So I think now it should work. Okay, nice. So that was just a quick fix. I'll say that's 50% my fault. But this question is not too clear as well. But yeah, I'll say it's 50% my fault. So yeah, I guess I can explain a bit on how I solved this problem, like although it is quite straightforward. So how I thought about this is well, we want to find the node with the minimal maximum depth, right? So how do we do that? And for our graph, there are two things that I think like whenever you deal with graph, you have to think about what kind of graph it is. So in our case, we know that the graph could contain cycle, so that's the first barrier. The second barrier is that our graph could have multiple components. So what I mean is, if you have something like, if you have something like 1, 2, so they can form a cycle, right? And then you have 3, 4, they can also form a cycle. So like something like this, you have connected component, like you have multiple components and you also have cycles in there. So how do we deal with that? Well, actually, I guess this is like something you just have to know by doing a lot of questions. But for BFS, it kind of just deals with these two cases straight away. So I think like especially whenever you're trying to find the depth of nodes, BFS is always a very good choice because you can do that in ON time, like to find the depth for all the nodes. So like how does BFS deal with the cycle and different components? Well, when you do BFS, it actually only looks at its connected component already, because like it cannot BFS out of that, right? So that's the first problem solved. The second problem is for cycle. But actually, if you look at the code here, we have this thing, right? So that means like if we have seen a node already, we will not go back into it again. And how is that optimal? Well, if you think about a BFS for something like this, right? Something like this. Well, because like we are looking at the depth sequentially, so like we'll look at zero depth and like first depth and second depth. Well, so if we have seen 3 in the first depth, and then we are seeing it in the second depth, well, we know that like from 1, like because we have seen it already, it has a equal or better depth than what we are going to see here. So that's why like we don't actually have to go back into it again. And by using a map, we can do that in ON time. So yeah, I guess like after you get those two things, it should be pretty trivial to think about how the other stuff could be done. And like of course, it's just like reading comprehension here, like for this part. And yeah, I think that's about it. So yeah, if you have any questions, make sure to comment below. I'll try to answer them. And yeah, thanks for watching, and I'll see you tomorrow. Bye.